Hey guys, this is Mr. Win, and we're going to talk about finding the x and y intercepts of graphs, linear functions, linear equations. Okay, so we're going to look at graphs, we're going to look at tables, and we're going to find the x and y intercept. We're going to even graph from just an x and y intercept. Okay, so what are x and y intercepts? Well, here's the definitions. Okay, so x-intercept is the x-coordinate of a point where a line intersects the x-axis. So if I have a graph where it crosses the x-axis, okay, it's that horizontal axis, the x-coordinate of that point where it crosses. And the same case for y, except the y-coordinate of a point where a line intersects the y-axis. So when it intersects the y-axis, that point, that y-coordinate of that point, okay? Now if I think of this for a second though, okay? If you've got a graph, all right, and you're looking for the x-intercept, start with x, okay? It's on the x line, so it's on the x-axis, right? So if it's on the x-axis, you'll notice that it doesn't move up or down at all. It just moves along the x-axis. Those are where your x-intercepts are. So if that's where your x-intercepts are, right, the y, it doesn't go up or down. The y-coordinate point is always 0. So just a way to remember this, if I'm looking at x-intercepts, and I'll write this here, x-intercepts are always when y is equal to 0, okay? And vice versa when you got y-intercepts. So if I have y-intercepts, if I'm looking at this, your y-intercepts is where, you know, that line crosses the y-axis, so that point. But notice all the coordinate points are 0 for the x. So vice versa, if you're looking for y-intercepts, and I'm just going to write that here, y-intercepts, that is when x equals to 0, because it doesn't move left or right at all. You're only moving up or down looking at intercepts. That's all you look at. But those points will never move left or right. Okay, so x is always 0. So keep that in mind. That's something we're going to use when we're finding this. If you're finding x-intercepts, y is equal to 0. If you're finding y-intercepts, x is equal to 0, okay? So let's look at some examples. So this says to find the x and y intercepts of each example. So I've got a graph, I got a table, all right? By definition, okay, if I want to find x-intercepts, it is where it crosses the x-axis. So if I look at a graph, see where it crosses the x, that point would be right here. Okay. And what point value is that? Well, that's going to be -3, 0. So that means for this first example, your x-intercept, I'm going to abbreviate int, is -3. Alright? Now let's look at the case for y-intercept. Y, where does it cross the y-axis? Well, it crosses it right here. Alright, there's our y-axis. And what point is that? Well, if I look at that, that's going to be up 3 over 0, up and down 3. So 3 would be your y-intercept. Alright. And again, notice, look at those points. If I'm looking for x-intercepts, our second value, our y, is 0, right? Okay. And if I look at the x-intercept, notice how I labeled that point out as 0, 3. The x is 0, but the y is 3. So if we're looking at y-intercept, alright, x's are always 0. If you're looking at x-intercepts, y is always 0, okay? Don't forget that, alright? And it helps. If you label out the point like I did, you'll notice that it's always 0 for the other value. So if you're looking for x-intercept, y is 0. If you're looking for y, x is 0, okay? What about tables? Well, applying that same rule, okay? If you're looking for the x-intercepts, and I'll look for x-intercepts, when is y 0? Well, the y is in the second value, so I'm looking here, and I see that 0 is there. That means your x-intercept is -4. Okay? Same thing with y-intercepts. So if I look at a y-intercept, where is x 0? So if I'm looking at y-intercepts, I got to find when x is 0. It's right here at 6, so y-intercept is 6, okay? Don't get those mixed up. I know it's very easy to, but remember, your x-intercepts is when y is 0. Your y-intercept is when x is 0, so kind of flip-flop there, okay? Alright, so let's move on. Let's do another example. Alright, so it says find the x and y intercepts of the equation 2x plus 5y equals 10 and graph the equation. So this is a little bit tricky because you're finding the x and y intercept of an equation that doesn't look like it's in slope-intercept form that we learned last time, right? This is what's called standard form. So I'm going to write this here, but that equation there is actually in standard form. And what that means is the x's and the y's are on the same side. We'll talk about standard form more later, but notice how the x and y are the same side. But, okay, if we apply the same rules that when you find the x-intercept, okay, y is equal to 0, and when you find the y-intercept, that's when x is equal to 0, you can still solve and find these intercepts, okay? So, if I want to find the x-intercept, and I have the equation, let's look at this, get 2x plus 5y equals 10. Let's go ahead and plug in for y is equal to 0. So if y is equal to 0, 5 times y would just make that 0. So what it would kind of look like is this, 2x plus 5, but instead of y, we'll plug in a 0, okay? Alright, notice 5 times 0 is always just 0, so really, that's just gone every time. Alright, so whatever numbers with the y, that's always going to be 0, because if y is 0, 5 times 0 is always going to be 0. So if those cancel out, you're just left with an easy, simple problem of 2x equals 10. How do you solve for x? Well, divide both sides by 2. 10 divided by 2 gives you x equals 5. That is your x-intercept. Okay? Our x-intercept is 5. And if I do the same for your y-intercept, so if I'm solving for y-intercept, right, and I'm going to do it to the side here, but same equation, but instead this time if I'm looking for y-intercept, I have to plug in x equals 0, so you've got 2, but instead of x, let's plug in a 0, okay, alright, and bring down the rest. Okay, now 2 times 0, again, that 2, really, you can just ignore it. It's always going to be 0, right? So, all you're really left with is a really simple problem, just like finding the x-intercept of 5y equals 10, okay? And the easy way to solve that, get the y alone, is to divide by 5 to both sides. And you're left with y equals 10 divided by 5 is 2. That's your y-intercept. Alright, and let me show you how to graph these, okay? Remember, if x-intercept is 5, that means on the x line at 1, okay, so I'm going to count this 1, 2, 3, 4, 5, that is where you'll have a point. Okay? And for the y-intercept, if the y-intercept is 2, let's count that over. Here's 1, 2. That's where your y-intercept is. That's where it'll cross. Now if I just draw my line, let's just draw a line where it crosses both. Okay. You have a nice and easy line, easy graph if I just have the two intercepts, okay? So kind of like what we did last time, graphing just the intercepts might even be easier to draw your lines, okay? If I know where it crosses the y, know where it crosses the x, draw my line, and hey, I've got the graph of that equation. Okay? Let's do one more example where it's kind of a real-world situation here. Alright, so I've got a paper airplane was thrown from the top of a tall building. Alright? That the height of the paper airplane above the ground can be found using the function y equals negative 2.5x plus 50, where x is the time in seconds the airplane has been in the air. What was the height of the paper airplane when it was initially thrown, and how many seconds did it take the paper airplane to reach the ground? Alright, so we got an equation, okay? This is actually in standard form. So let's look at the equation. So I've got y equals negative 2.5x plus 50. Okay, I gotta know two things. I gotta know the height of the paper airplane, when it was initially thrown. So if I just imagine this, right? Just imagine a situation where here's my building. Okay, I got some windows. All right, awesome. An airplane was thrown from the top and hits the ground here. Okay, it's a linear function. All right, so it was if I graph that equation, right, you notice how the slope is a negative 2.5. That means it is decreasing. It is a negative slope, right? So it is going to go down. This is kind of what it's going to look like, right? Okay, so if I had an equation and I was able to graph it, I need to find out what the height was. So the height, the initial, let's do this. The height it was thrown from, all right? The height the airplane was thrown from. And you also got to find how many seconds, so how long did it take for the plane to reach the ground, all right? So notice how I need to go up, find the height, but also to find out the time and amount of seconds till it hit the ground. So there's two things you got to find out here. When it was initially thrown, that's one of those keywords, when it was initially thrown, that is going to be your y-intercept, okay? And you also got to find when it reached the ground, that will be your x-intercept. So if I can graph this equation and just find the y-intercept and the x-intercept, right, you've got your answers, okay? So I'm going to erase my little demonstration there, so I got a little room to work with here, but okay, so again, if I want to find, let's find the x-intercept, okay? Let's start with the x-intercept. So if I want to find the x-intercept, that means when y is equal to 0. So if I solve when y equals to 0, you can get an equation. So I'm going to replace the y with the 0. Alright, and write the rest of the equation and just solve for x. Alright, so if I start solving this, notice the 0's over there, so I've got to subtract 50 from both sides. Alright, that cancels. This gives me negative 50 equals negative 2.5x. Okay, and now this is one of those problems just like standard form kind of, where it's just that one step where we have to divide. So I'm going to divide both sides by negative 2.5, and we should get an answer of negative 50 divided by 2.5. That is actually going to be 2.5, that'll be 20, so 20 equals to x. So our x-intercept is at 20, all right? And if I want to find the y-intercept, all right, let's find the y-intercept. Same situation, you've got your equation, but we have to plug in when x is 0. So if I write my original equation, but instead of writing x, I will plug in the 0. So instead of x, I'll plug in a 0. All right. You notice that negative 2.5 and 0 kind of cancels each other out. So y-intercept is just, I don't need to write that plus anymore, 50. Okay, and this follows your whole standard, slope-intercept form, where the b value out here, the b value in our original equation, the b value is your y-intercept. So that's something we already know, and notice how the math kind of works out. Okay, so if that's something, if it's already in slope-intercept form, what's one of the easy things to find out? So if you know those two values, okay, let's just actually graph that. So if I graph the x-intercept at 20, let's go to my graph. How about we count by 5s, and we can reach 20, yeah. So let's say this is 5, 10, 15, 20. That's where my point would be. And then let's graph our y-intercept of 50. 5, 10, 15, 20, 25, 30, 35, 40, 50. Yeah, it'll reach 5, 10, 15, 20, 25, 30, 35, 40, 45. The very top is 50. Okay, I have my 2 points. I can draw a line that crosses those 2 points, and you've got the graph and the x and y intercepts of this real situation of a paper airplane being thrown from a building. Okay, alright, that's about it. Good luck on your assignment, and I'll catch you guys next time.